Is a basic modeling example using the Wendy's application area we discussed in class in the Union. Um, First of all, we have to have arrivals to the system, so we do this with the create node. And we're going to assume that the time between arrivals is exponentially distributed, so we click the function key, random functions, and scroll down until we find exponential. And we'll assume that the arrivals are once a minute. This is kind of during the early, just before the noontime rush. We're going to create an infinite number, and we'll also add a node label just to say start um, the system operation. Okay. Next comes a queue node, so we'll drag one of those up. This represents the waiting line for the burgers. So this will be file number 1, first queue, initially 0, infinite capacity, so there's no full action to be prescribed. Next, we'll add a goon node. Goon node is just kind of a connector, doesn't really do anything. So this gives us a place to put the service activity between the wait node and the goon node. So we click on the activity button, move the cursor into the wait node, it turns red, we click on it and make it into the end node for the activity and click again. And then we'll kind of default all the fields except for duration. Again, random functions. We'll assume that the service time is pretty much the same as the arrival time. Well, let's make it a little longer. So we'll say that it takes 3 minutes on the average to get a burger. Okay. We need maybe a couple of servers in this application since the arrival rate is higher than the service rate. So let's assume that we have 2 burger servers at this location. Okay. Now we want to connect when the arrivals come to when they get to the queue, so we need another activity, but this is a regular activity. So we click on the start node, click on the end node, and we'll assume it takes people from they walk in the door till they get to the Wendy's waiting line 1.5 minutes. We can default the rest of this. We don't put a certain number of servers since this is not a service activity, so there's no service item required. We're going to go back to the create node and add arrival time collection where we fill in the save tnow field, and we'll set this to attrib 1. So whenever we have an arrival, the arrival time will be stored in attrib 1. Next, after service, the customer's ready to leave, but we're going to collect time in the system statistics before the customer departs. So we'll grab this collect node and drag it up to the model. We've got to give these numbers. We'll call this collect node 1. And the value is the value we're going to collect, which is tnow minus attrib 1. Time in the system, add an ident for TISYS. We won't collect histogram information right now, but we'll click OK to add that collect node, connect those two with an activity. Activities can be zero-time activities. This will be an example of that. So the duration we'll assume is just a logical flow. We don't really have any physical duration. So we can default everything on the activity. Just click OK and it's completed. Next we need a terminate node to leave the system. Okay. Again, this can all be defaulted, so we just click OK, and then we click on the another zero-time activity to link the flow together. So now we have the flow from the beginning all the way through the end of this particular model. We want to save the model, so we click on File and Save As, and give it a name. In this case, we're going to call it something like Net1. Don't forget, in naming files, you can't use any special characters. It's you have to limit your file name to 8 characters, as this is says some legacy features on the file naming process. So we give it a name, click OK, and then we're done with creating the model. Next step is to link the model in with this scenario. So we're going to select the network net1, add it to select networks by clicking the left arrow, click OK, and now it's in our list of networks. We'll quickly build a new control model, which we need to run the simulation. And in this case, we have a gen statement. Can you put your name here, project, date, and number of runs? In this case, we'll just do run, one run. We'll say Grant and Wendy. We'll leave the rest of the items defaulted. Limits tells us how many attributes or global variables we have, so don't forget to set attribute 1 equal to 1. We have one attribute. Okay, and then we have to add one other entry called initialize, and this tells us how long we're going to run it. So we'll run it for, say, 200 time units, just to get a good feel. 200 minutes, click OK. That added that initialize statement. And then next thing to do is to save the control model. So this will be control 1. Save it and close this. And in the control models, we have it as an available model, but we have to set it current to associate it with the current scenario. Okay. Now, in order to run this, all I have to do is click the report icon, and the model will be translated, run, and I'll get some output. It looks like we have an error, so let's check out the report output report on the echo. And looks like I misspelled attrib instead of ATRIB. I spelled it ATIRB. So we'll close that. So don't forget report output echo gets you the echo report where you can find errors. Have to reopen the network to fix the problem. Here we have where attrib is misspelled. I double click it, go down here and edit it. ATRIB, all capital letters. I'll use capital letters in any awesome variable. We're going to save this particular network. We've already named it. Close it and run the simulation again. This time it runs fine, and here's the output report. So this is time in the system, 29 units. Quite a few people in the queue, 26 people. And average waiting time is 27 minutes. Far too long for this to be an acceptable application. So in the next video, we'll talk about how we can modify this application and increase the performance.